past, but there's nothing I could change. I have to be here. So we are going to look back at some things that happened, and what I'm going to do, I will still go back to 6.2 a little bit. Control room, I don't know if you can hear me, I don't know who's there right now, but can you bring the volume a little bit down?
Our volume? No, it's control room. Oh.
No, I'm talking about here because you guys in Medic are kind of loud. I'm not saying you are loud, but the sound here is just too loud. So hopefully they will adjust the volume. All right, so at least, well, I'm trying to think, Medic guys, when you were here, when the day when we look at 6.2, I think you were here. And then on Tuesday, right? We looked at 6.3, so at least not this Friday, but Friday before, we looked at 6.2. So I will refresh 6.2 again, and then we'll go to the new method, the one that we started last Tuesday. So kind of will be mixed, just to make sure you see the difference and get some ideas. So let's start working now. What number is this going to be? If we're 13, this will be 3?
It's 3. And 4.
So what is this one?
I have 4.
So this will be 5 or 4.
I have 3 props, and this would be 4.
Okay, and what was the last? So what was the last problem we did last time? If you
x minus x squared.
Okay, all right, good. So let's just go to 4 right here, and let's say we have y equals x squared, x equals y squared, and we're going to rotate this about y equals 1. And I know it's kind of a little bit difficult to come back and remember many things, but we'll see. So we're looking for the volume of the area by rotating it about y equals 1. So we have to put this picture together. And again, remember, your calculator is saying, well, I need only y equals. So I'm going to put y equals for this one right here. And if I take the square root, right, I have to put plus or minus square root of x. So this is what I have. So let's get to the calculator and see what we have, just to make sure we have the right graph. Now let's see guys here. I don't know, I'm always suffering with this PowerPoint. Come on. Okay. So let's graph them. So the first one is easy. This is just x squared. Now the second one will have square root of x. And then the next one will have negative square root of x. And remember, we're looking at the picture and we will be deciding, do we need all the curves or just some of them? So when we graph, we have a parabola, that's the first one, and then we have square root, positive, then we have negative. I'm going to zoom in. So this is what we have. So it appears that negative square root is not involved in the process. So the area that I'm dealing with, that kind of little leaf or something, whatever how you want to look at this. So we're going to put this on the graph, and keep in mind you're rotating this about y equals 1. So give yourself some room, and please practice sketching, because you will have this on the exam. So for example, let's say this will be the, I'll have to go back and you can see it. So this will be my parabola, and this will be the square root. So we have something like this. And I'm rotating this about y equals 1, so that's the horizontal line. Now please make sure you have the right line, because I see at least 2 students every semester. For example, it says y equals 1, but on the graph they put x equals 1. So make sure you know if it's horizontal or the vertical line. So don't kind of change this because that will be completely wrong. So here's the rotation that we have. It's y equals 1. And as the result, we'll get something like this. You know, it's not a perfect graph, but something like this that we'll create. So kind of this piece. But don't forget, the original piece is right here. And we're only working with it. So any questions about the picture? All right, so let's talk about volume here, but let's go back to 6.2 again, just to refresh. So with 6.2, I have to deal with cross cut, right? And this will be my perpendicular cut to the axis of rotation. And remember, I'm just putting the line, but in reality, it's the washer. Remember, when you do this, for example, I don't know if I should, but I'll do this one more. So this will be this, and then you will get something like this. So this will create that washer that we're dealing with. So we will call this washer method, again, or disk, it depends what we have. And please do the same thing on the paper or exam. You have to tell me if you're going to use washer or 6.3 method. We'll talk about this in a moment. So I'm saying I'm using washer. And the next question that I have, which is very important, for washer method, is it dx or dy?
dx.
And this will be dx. One more time, how do we know that we have dx? Because our axis of rotation is parallel to it.
X-axis.
X-axis. Or if it's x-axis, then we know it, right? So if axis of rotation is parallel to x-axis or x-axis, it's dx for washer. Or if axis of rotation is parallel to y-axis or y-axis, is dy. So here I have dx, right? Okay, now the other thing is what you have to remember, and probably this should be kind of thought through right away, since this is dx, all my functions must be y equals, yes, no? Because your x is a variable, so y equals x squared is ready. This one already changed, y equals plus or minus square root of x, but remember, here's the piece that I'm using, so I'm using only positive square root of x. I am not going to use negative square root. Okay, so y equals positive square root of x. This is one of my curves, and this one. So one more time. You put the picture, you rotate. We go with the washer, so I have a little sketch here of that washer. Then you decide if it's dx, dy, and if it's dx, make sure all your functions are changed to y equals. If it's dy, then you change them to what? X equals, right? All right, so this is what we have as a setup. Now, next thing that you have to remember, again, I'm really refreshing this. If we're using washer or disk method, the formula, now keep in mind this is a general formula for the volume, is integral from a to b. And here we have a of x dx. That was the idea behind the washer disk method. And what was a of x? It was the area of this cross section. Basically what? The area of this washer, right? That was a of x. Now, if my equation it will be, well, my integral will be in terms of dy, then it's not a of x, it's what? A of y, right? So just to make sure you understand. So I have to get this function first, and then I'll put this into integral. So my function here will be a of x. And remember, you are looking for the area of that washer, and we talked about this. In order for you to find the area of the washer, you have to find the area of the outside circle, basically what? The whole thing, right? And then you have to subtract the area of the inner circle. I think we're clear here, right, on that? So in order for me to know the area of the larger circle, I need to know the radius. and we said this before, you always look for the area from the axis of rotation to the outside curve. So one more time, I know it's a little bit difficult to see, but you go from the axis of rotation, which is y equals 1, and the radius, it goes up this, right? Right here. So the distance from here to right here.
1.6.
Okay, and you have to be very careful, right? You have to be very careful. It's not something that you can iffy over here, like today I know, tomorrow I may forget. You really need to know, this is I understand, this is the distance, and it's always right. So one more time, the distance from here to right here, or if I can project from here to right here, this is the distance that I'm looking for, okay? From point of rotation to the outside. And this will be 1 minus what? X squared, that's right. This distance from here to right here is 1 minus x squared. Now, we may have a little difficulty here with the idea, okay? So maybe, I'm just debating how can I show you this, okay? But overall, let me put this on a separate piece of paper, just in case some of you are still kind of struggling with this. But take a look. Don't write this, I just want to make sure you see this. And I make this large. So this is one piece, and this is the second piece. Okay. So you want to know distance from here to this curve. That will be your outside, right? Radius. Now, if you think this in terms of geometry, and I think I mentioned this before to you. So overall, I will consider this as one piece, okay, from here to here. So let's say this is A, this is B, this is C. Okay, and what are we looking here for?
AC.
We're looking for AC, right, for this radius. So what is AC? AC will be what? AB, which is what? The entire distance minus tiny little piece, which is what? CB. Well, if you go back to our picture, the entire distance will be 1, right? And then distance to this point over here is just the distance to the curve. And this distance over here, okay, I'm trying to mess around with the picture, but this is the distance over here, will be just what? X squared. So 1 minus x squared, okay? You have to practice this. So that's why we have 1 minus x squared. So the radius is 1 minus x squared, but the area is what? Pi r squared, right? So we'll have pi, and then what? 1 minus x squared and what? Squared. So this is the area of the larger circle. Then we do minus. Now area of the small one, right? If I go back over here, well, and if I probably change the picture because my point C will move over here now, okay? Because I will be looking for this piece. So if I push this back and change it again. So now I'm looking for distance from here to right here. This is my distance. But the idea is still the same. This is A, this is B, and this is C. So AC is what? AB minus CB, right? Well, AB is still 1, but then the distance to C from here, right? Because that's from the axis, x-axis to the curve will be just what? Square root of x, right? So here, the radius for the smaller one, I'm not writing like I did before, r big, r small, right? But this radius to this piece will be 1 minus what? Square root of x, and again what? Square. So this will be the a of x. This is what we have for a of x. So overall what I see, and again from many years and from the experience, that this is the most difficult part, to set up the function. If you have the function, then you really have an easy task to actually get the volume. So when we get this right, we can say we're almost done, and we will have no problem to actually calculate this. So now what I do, I'll put this into integral. So with the integral, I have volume integral, and the next question from what to what?
Here at 1.
So remember, this is dx, right? So you're looking at x-axis and see where you have to go. So you're right, it's from 0 to 1. Here's your 1. So we have from 0 to 1. Integral from 0 to 1. And now we can actually pull out this pi outside, okay, this pi from our formula. And then inside you have 1 minus x squared minus 1 minus, and let's put it x to 1/2, okay, here, because you know we have to deal with the power function right now. Well, this is your integral. And this shouldn't be difficult to calculate because the function inside is very simple. We just have to open parentheses. So we have 1 minus 2x squared plus x to the 4th. That's what we get with the first piece. And here I will be squaring this, but then also I will open parentheses. So we have negative, then we have 1, then we have plus 2x to 1 over 2, and minus what? Minus x, that's right. And dx, right? If you square x to 1/2, it will be just x. All right. Well, we'll combine like terms, so it's from 0 to 1. The only good news here is that 1 will be canceled, but everything else will stay. So order doesn't make a difference. I just want to keep positive first. So I'll put x in the first minus 2x squared minus x plus 2x to 1 over 2. So I put them in order, but it doesn't make a difference. Well, and the rest should be easy, right? To get antiderivative. So we get pi. Here we get x to the 5th over 5 minus 2x cubed over 3 minus x squared over 2 plus, and here what do we get?
4/3 x at 3.
Okay, perfect. So from 0 to 1, right? So when we substitute, I mean it's 1 over 5 minus 2 over 3 minus 1 over 2 plus 4 over 3. And if you substitute 0, you get to 0, right? So as the final answer.
11 pi.
Okay, so 11 pi over 30. It's just the calculator work, right? All right, so that was washer method, the idea again, or disk, but can be more specific, we have washer. So most of you, again, have seen this before, that's section 6.2. Well, now let's go and refresh using the same problem and refresh shell, but some of you will learn shell from the very beginning. So let's take a look and understand the idea. So what I'm going to do, before I actually will go to that problem, okay, if some of you already understand the math, the shell method, then it's okay, you can just do it. But let me explain again to those who were not here the idea. So if we have a disk or washer method, okay, let's take a look at this, disk washer method. So let me explain again or refresh the idea of rotation and what we're trying to do. And then we're going to look at the shell method. So if I have some function like this, for example, and this is my area that I will be rotating about y-axis. Okay, so we understand that we're going to get something like this, and this will be kind of like a cup, but what's so special about this that it doesn't have any, well, it's not hollow, right? It's what? Solid piece, right? Because you're rotating this entire area. So with the disk and washer, the whole idea was based on what? On the cylinders, right? You do the cross section, and for example, with the cross section, you get a circle here, and remember, with the washer or disk, you do the cross section perpendicular to the axis of rotation. And now, normally, I shouldn't say normally, but I didn't ask you to do the 3D kind of thing, like you do really cylinder here. I told you just to do the cross section to make sure you see if it's a disc or a washer, right? That's what we talked about this. But in reality, what we have here, if we do this, we have small cylinder, okay? Kind of small like a pancake thing, okay? And we have a lot of them here. I'm not going to do a lot of them, but again, the whole idea, we have a lot of those cylinders, right? And we say what? It's a limit of Riemann sum when n is approaching to infinity. That means a lot of these things inside. So that was the idea here, okay? And the formula was, again, one more time, the formula was integral from a to b. This will be a of y dy. Do you understand why? Because you're rotating about what? Y-axis, right? So, and that's the idea of a washer or a disc, okay? Cross section. And like I said, we have a lot of these pieces put together. Obviously, they have different radius, right? That's we understand. Now, the next question is, okay, how's that shell method is different? So let's put shell. And when we say shell, again, you know, if you go to dictionary, shell can have many different meanings. Well, in mathematics specifically, to make it easier to remember, shell we consider as a pipe. Okay, so that's what we have, pipe. So if you go back to the picture, it's the same picture, okay, the same volume, but completely different method. So what's going to happen? Well, I still have the same thing, okay? That doesn't change anything as a shape. Okay, well, trying to do my best, but this is what I have. Now, the shell method, the whole concept, based on the idea that you take these pipes and start putting one inside of the other one, and basically that's how you fill in the gap. So what that means, now watch, because I cannot make this the best, but I'll show you later in the moment, again, mainly medical for you, I'll show you in the moment some little animation kind of to make sure you understand the process. But basically what that means, look, first of all, you have to remember, when I'm going to fill in this gap, this volume with the pipes, all pipes will be positioned parallel to the axis of rotation, not perpendicular like over here, but they will be positioned parallel to the axis of rotation. So basically, look, what are you going to do? Well, the first one, if it's a solid, obviously I have like a steel rod over here, okay? This is what I'm putting in. So it's like one solid piece goes in. Well, then I'll put a pipe around it, so this will be really like a pipe, okay? You're putting a pipe right here. And then you put another pipe around, and again, I'm running out of room here because I don't have enough, okay? But basically, you put pipe inside of pipe. And what's happening, you will try to fill in or get everything inside and close or put together with these pipes. And if you look carefully, each pipe has different radius, first of all, but also each pipe has different height, because look, if my curve is climbing up over here, well, obviously the pipe will get shorter and shorter. Do you understand that? So basically that's the idea with the pipes. You're putting pipe inside and inside, inside, and you will fill in the gap. That's the idea. So if I quickly can show you this, that's the wrong one. A little kind of animation, and there's nothing special, okay, but to make sure you can see the idea. But this is the idea, okay, let's start with this. And you guys, I know I didn't show you this last time, no? Trying to remember this now. But basically, look, all of these divisions right now, when you're looking at them, they are parallel to the axis of rotation, because axis of rotation is what? Y-axis, right? And then you get this little one, this is only one. You see how a pipe goes, right? So this is just an example with only one pipe to make sure that you can visualize this, how pipe goes inside. So this is only one. But if you see this all divisions, I don't know if you can see this on the screen, Medico, but what we see here, you see a lot of divisions. So each of these divisions will represent what? Separate pipe, right, when you start rotating. So all of these pipes will close the gap. But it's a little different approach. The previous one talks about cylinders, right? Here we're talking about pipes. So now let's take a look at the same example, but now with the whole piece. So you see the inner one will be the solid piece. Then you have this blue pipe, okay? Then you have another pipe. Then you have another pipe. And now they're doing just halves, but now they will rotate the whole thing. Now, obviously, you're not going to draw this on the picture, okay? It's very time-consuming and kind of messy. So this is what we have. Maybe I can show you one more, something like this, when we have a little bit different picture. So you see, these pipes that you're putting in, they have different height, right? When you follow the curve. And then you just start rotating it and you'll get your 3D kind of piece. So that's the idea behind. Now, don't get really kind of preoccupied with the beautiful picture, okay? I don't care about beautiful picture. And I'll show you what I really want to see when we do this, okay? But that's the idea. So the question is, all right, I've seen it, and I understand how it goes, so what's the formula that I can use? Well, the formula goes like this. You get integral from A to B. And, well, remember, your A and B will come from the axis that you're considering as your rotation or parallel to it. Like this one, it was y-axis, right? So A and B will come from y-axis. If it's x-axis, then it will come from x-axis. So, how do we do the formula? Well, first of all, the biggest difference here we have is actually the variables. Because shell will be not dy, but shell here will be dx. Okay? Shell here will be dx. And this can save us sometimes when we're trying to solve the problem, find the volume. So overall, let's do this. If you, for example, working with shell and you're not sure if it's dx or dy, first think about what? Washer. And washer is easy to recognize. Parallel, right, to x-axis, that means what? Dx, right? Parallel to y-axis means what? Dy. So this was parallel to y-axis or y-axis. This is dy. Shell will be just what? Dx, just opposite, and that's it. Okay, shell will be opposite. So not too much to think about. Shell is always opposite. So if you know what washer disk is, shell is opposite. But the formula then goes like this. 2 pi x. Now keep in mind this formula in a very simple form. I'll show you something a little bit more complicated when we have to modify it. But formula this gives you just simple form, something like this. So what is 2 pi x? Well, 2 pi x will be circumference of this shell. And overall, it's the average circumference. Why? Well, think about the volume of one shell. Okay, so if I put something small over here, like this. Well, trying to do my best, okay? So, one shell. If I say find the volume, what would you do?
Outer circle, one circle.
So what? You find the volume, the entire piece, solid, right? And then subtract what? The insert little piece right inside, right? Well, here, the formula was developed with the idea that when you put a lot of them, the thickness of what? The shell will be what? Very small, right? Instead, it will be very small. So almost you're going to lose that volume. There will be like only a thin piece, kind of, you know, like a foil or something, very small. So here, actually, this is not circumference of each of them, but what? It's the average circumference, okay? Then what we have here, we have f of x, which is the height of that shell. Okay, so height, how tall that pipe is, that's what we have. And then we have dx. Well, dx, if you go back to limit of Riemann sum, will be what? Delta x, right? Which is what? The thickness of the shell. Okay, it will be just dx, well, delta x will be tiny little as we have a little thickness of that shell. Well, this is the formula we have to use. Okay? This is the formula we have to use. So now let's go back to this problem again, the previous one, and use shell method just to see the difference. So for number 3, no, that's not 3, that's my number 3. What is yours? 5, right? This will be 5. So we have the same thing. Y equals x squared, x equals y squared, and we're rotating this about y equals 1. So the picture doesn't change. So we have this, x is a rotation right here, y equals 1, so something like over here. Okay, so this is what we have. And before anything we put on the picture, we're going to write that we're using shell method. And the next question, dx or dy?
dx, dy,
Okay, so we need to make sure, right? So remember how I told you. You think about, for example, washer, because you learned about washer before, and maybe you know it better, let's say. So for the washer, previous example was what? Dx, right? And this will be opposite, so what do you get?
dy.
dy. Now, if you just see this dy, okay, you see this dy right away over here, then you know everything that you have over here must be changed to what?
Y.
X equals, right? So here, this one must be changed to x equals what? Square root of y. And now I should put a plus or minus, but based on the picture, I have positive. Okay, so I'm not going to put plus or minus. So we will be using this one, and we will be using this one for our integral. Well, the next thing, since this is dy, remember we're always looking at the original. There's only this piece. So what will be upper and lower limit?
0.
So from 0 to 1, right over here. So this will be 1. Again, I'm putting this one kind of big, but from 0 to 1, right? From 0 to 1. So don't look like how tall the shape is. This is really irrelevant, because if it says dy, you look at y-axis, right? How tall. Or if it's dx, you're looking how we have it here, right? With x-axis. So this is what we have. And now what's different? Okay? Remember, we're not going to slice here, because it's not washer or disc. What you're going to do, you're actually going to put pipe inside, right? And for the simplicity, we're not putting pipes and making this too complicated and difficult. What we're doing here, we're only putting one little rectangle over here. And please do not forget, this rectangle over here will determine what? How tall the pipe is, right? Because remember, you're rotating it in this way, so you're creating a pipe. I just don't want to overload the picture, but remember, if you start rotating this little rectangle, you create that pipe, yes now? Okay. Now, since your pipe always must be parallel to the axis of rotation, so that's why this pipe is horizontal. Comparing with this one right here, it was what? Vertical, right? But here it's horizontal because my axis of rotation is horizontal. And when you put this in, automatically put y over here. Now, what is y here? It's the distance from the origin to your what? Rectangle, do you understand it? It's the distance from the origin to the rectangle. This is y. Well, that's all you have for shell method as prepping, okay? The preparation. Well, let's start putting it together. So volume. We already said that we go from 0 to 1. The next question, well, I have to work with the circumference, right? And circumference is what? 2 pi. But the question is, what is the radius for this shell? And radius always goes from what? From the axis of rotation, right? So look, if you will rotate this, again, I'm not going to do this anymore, but let's say you're rotating this, what's going to happen, you will have something like this, right? Yes? You'll get that pipe like this. So your radius is not from here to here. Your radius from here to right here. So the question is, what is the distance from 1 to y? And you should know this. That's right. It will be what? 1 what? Minus y. Can you see that? Yes, no. It's not y. Distance is not y. Because you moved your axis of rotation. So the distance will be 1 minus y. So this is very important that you know the right radius. It's not always 2 pi x or 2 pi y. It's not. If you move your axis of rotation, that's it. You have to be very careful. So the distance again from the axis of rotation to y is 1 minus y. Okay? That's the radius. Well, the next, if you look back at the formula, it says f of x. But remember, f of x determines what? The height, right? So the question is, what is the height of this little rectangle? So what do you think? Now, what if I rotate it this way? Can you tell me what the height of this rectangle? That means what? The top minus the bottom, right?
That's y minus y.
So the only thing here, you have to be careful to know what function to pick, right? Don't forget, everything has to be in terms of y. So over here, this curve is what? It's square root of y. No, this is your square root of y, so you have to be very careful. So this will be what? Square root of y minus, and this one will be what? Y what? Squared, right. And dy, and you're done with the integral. Okay? So we're done with the integral. So I don't know, look again. So what's important? To determine if it's dy dx, right? The next thing, what's important to solve all your functions, like for this example, since I have dy, to solve everything for x. The next thing, to put the rectangle. And this rectangle will be parallel to axis of rotation. So if you put the rectangle parallel to x-axis, just put y over here, this will be the distance. The next step, upper and lower limits, they go with the variable. dy means y variable. And the next thing with the formula, you go with 2 pi x or 2 pi y, but you have to remember, I'm looking at the picture and I see that the radius is not y. The radius is what? 1 minus y. And also how tall the rectangle is, that will be determined by the curves. Well, this is the setup. So let's work with this. So 2 pi will go outside. Then we have integral from 0 to 1. We have to open parentheses here. And what we're going to do, we're going to keep exponents here. So this will be what? Y to 1 over 2 minus y squared minus y to 3 halves plus y cubed dy. So just opening the parentheses. Well, the bad news, there's nothing to cancel. But good news, it's easy to find antiderivative. So 2 pi, here we'll have 2y to 3 halves over 3 minus y cubed over 3 minus, what do we get here? 2y to 5 over 2 over 5 plus y to the 4th over 4th, and this gives us, oops, I don't have, well, yeah, from 0 to 1. I felt like I already substituted, but I didn't. So 2 pi, we're substituting 2 over 3 minus 1 over 3 minus 2 over 5 plus 1 over 4. Putting 0 gives us 0. And the answer is, same as before, right? What do we get?
11 pi.
11 pi over 3. Now, if you would say, like, which one's easier over here? Well, it doesn't make a difference for this example. Really, it doesn't make the difference, any difference. They're kind of equally the same. There are little things that we have to deal with. Maybe for me personally, if I will just have to decide between washer or shell, I probably will go with the shell, just because if I go with the washer, I have to deal with these radiuses over here, or radii, if we say it right? All these pieces to determine. So if there's a chance, if you feel like it's better to go with shell, go with shell. If you don't want to go with the shell, then go with the washer. Okay, overall it doesn't make a difference. Now, so the question is, all right, so where is the difference? Like really, what's the purpose? Okay, it's just the second way of doing it, the new approach. Well, let me show you something. Let's go to example 6, and what we're going to do, we'll take the problem from section 6.2. And the problem that we had was like this: x, y equals 1, y equals 0, x equals 1, x equals 2. Again, it was the second lesson, that was Monday, I think, for 6.2, and we had to rotate this about x equals -1. All right, so I'm going to put the picture, we'll shift the graph a little bit to the right. So overall, as I did it last time, or when we learned this, in order for you to graph, you have to change, not this form. Remember, this is implicit form, x and y mixed. So this will be y equals 1 over x. So now I know how that looks like. So if you just think about y equals 1 over x, you'll get two pieces over here, right? First and third quadrants. But then all these pieces, x equals 0, y equals 0, x equals 1, x equals 2, they will be in the first quadrant, okay? So I'm going to ignore this piece on the bottom, the third quadrant, only working here. So overall, my picture, this is my 1, this is my 2. Now don't forget, x equals 1 is the line, right? It's not the point. X equals 2 is the line, it's not the point. But overall, this picture is going to look like this. So the top piece is 1 over x. The left one is x equals 1. The right one is x equals 2. But the bottom one is y equals 0. So this is the piece that we have to rotate. And we're rotating it about x equals -1. So if I rotate this, and I have to be very careful to keep the symmetry, it's not going to look something strange. I know it's always difficult to do it, but let's say, I don't know, something like this. This is what I have when I rotate. Now, I really want you to, if you were not here when we did this problem using washer or disk method, to go online and get the notes. But those who been here, do you remember the problem with this? What was the problem with this example?
It required 2 integrals.
You are required, yes. You have to use 2 integrals, not just 1. Again, if you go with the washer, your slice has to be perpendicular to axis of rotation. And if you look, you really have 2 different functions at the end. You have this x equals 2 function, but then over here, passing this point, you have this y equals 1 over x. So this will require splitting this over here. Okay, I'm not going to draw this, okay, because I'm going to use shell method, but this will require you to use 2 different integrals because of the outside radius. So one integral will be from 0 to 1 over 2. Here we'll have 1 over 2. And the other one will be from 1 over 2 to 1. 2 integrals, it's a great big inconvenience. But let's take a look at this problem from shell point of view. So, if I go with shell, is it dx or dy?
dx.
This will be dx. What about upper and lower limit? Well, you're looking at x-axis, right? So where's your picture? On what interval? From what?
Negative 4 to negative.
So what's the upper and lower limit? So we get from 1 to what? 2. This is what you have, from 1 to 2. So we know those things. The other thing is, everything must be solved for what? Y, because it's dx, right? So we have it, it's 1 over x, that's what we need. And the other thing is, I have to put my rectangle, so here's my rectangle. Remember, this rectangle is parallel to the axis of rotation, and I'm going to throw this x in, okay, this is my x right here. So the question is, when you're trying to set up that integral, it will be integral from 1 to 2, we just said this, from 1 to 2, that's all I have, 2 pi, and the question is, what is the radius of this shell or pipe? You're not sure? Okay, right. So look, the distance from the origin to x is what? This is x distance, do you understand it? From origin to x is just x. There's no 1 plus, do you understand that? From origin to x is just x. And then from negative 1 to 0 is 1 as a distance. So the radius from here to right here, this is your radius, okay? From here to right here is 1 plus x. Radius, again, look at the picture. I know it's going to be big, but remember, this is what's going to happen. You get something big pipe over here running around. So you get 1 plus x. The next question, what is the height?
1 over x.
1 over x and dx. And this is your shell method for this problem. You see the difference? So if I have to decide, I'm not going to use washer, okay? You try it, you want it, go for it. I have a second method that I can use, and I can go straight and work with the shell method. And that's the advantage of having a second different way of doing it. So I'm almost done. We'll put 2 pi outside. Then we have integral from 1 to 2. We're going to distribute 1 over x. So we have 1 over x plus 1 dx. Very simple integral to work with. We get 2 pi. Can you tell me antiderivative for 1 over x? Right, it will be natural log, but not just x, but what? Absolute value. Please don't throw it away because it'll take points out. Natural log of absolute value of x plus x, and it goes from 1 to 2. Very simple integral to work with, okay? So this is what I'm going to do. I'm going to put 2 pi outside, and everything else I will be working inside. So natural log of 2, you can drop absolute value here, because 2 is positive. Natural log of 2, plus 2. So that's substitution of 2 inside. I don't know, maybe you can put 1 set of parentheses extra. Minus, and then we're substituting 1. So you get natural log of 1 plus 1, and this is how it looks like. Do you understand? And then we get equals, we get 2 pi, and we have here natural log of 2. What is natural log of 1? 0. And then you get 2 minus 1, right? Which will be what? 1. And that's the answer. It was exactly the same answer as we had before, where it took a lot of time to use washer method just to go through the process. So that's the shell method, okay? And I mean, if you need more, I mean, you know, if you want to know where to buy something, you go to Google, right? Why you can't just go and Google extra examples, okay? See some animations. There's so much. Your book has good pictures, okay, when they rotate. I cannot do this on the paper, okay? I have to use different colors. And the camera is so bad that you cannot pick out the colors. So that's why it doesn't look good, but you can get more examples if you need. So quickly before we leave. The next exam, Monday, Tuesday. It's not going to be at the end of the week, not this week, okay? I want to give you more time, and if we have to refresh and all that, we'll do it. There's only one section left for me to teach, it's 6.5, which is very simple section to teach. There's only one formula that I have to give you, but we will be done. I'm not doing 6.4. I already mentioned this to you. So if we'll finish, we'll do the review, and again, like I said, the exam will be Monday, Tuesday. What that means, that your homework will be due Monday, not due Tuesday. Okay? Because you have to finish everything before you go and take the exam. And next week, like I said, we may start this week working on the review, but next week we will start reviewing. The whole review will be from your exams. Okay, I don't have any special separate assignments that I have to give you. Although you have some extra piece that sits online. It's your, if you look, I don't know how many of you look at Canvas, but there's like final review on Canvas 6, and that final is big. It's like 101 problem. This is not for the grade. It's up to you if you want to do it or not. I have this done for dual credit for high school, specifically designed because of the having extra time to review many things. But for us, we're going to go over the exams. So make sure you find all your exams, 1, 2, and 3, that you have them, okay? And I'll be going over questions and reviewing all the concepts. And then when we get closer to the exam time, final exam, I'm going to tell you specifically what you will have, what you will not have, because of the time. Any questions?
When is the final exam again? Like date, time?
No, this time I can't look at the syllabus, okay? I don't remember, really. And next time, we actually look at our beautiful puzzle to determine when the final is. Just to refresh, maybe I made a mistake. Just want to make sure we have the right time, and I think I did it right, but not will hurt us to look at one more time. But it will be, the week we're talking about final is what? It's the week of what? What do we have? Monday the 10th, right? That's what we're looking at. That's where the final exam. So you will have 2 hours to work. And the minute club, if you're planning to take the final, it will be at the testing center for you. The time will be limited. Okay, so it's not forever time. Time will be limited. And for us, we will have it here in class. Okay, so, alright, so I'll see you tomorrow. Please be here tomorrow. We'll do our lecture problems. And if you have any questions, please ask. Okay.
My parents left me behind.
Where did they go?
They're on
Is that a cruise?
Yeah.
It's a cruise ship?
They're at the Bahamas right now.
Gosh. That's ginormous. That's like
It
a
is
city.
huge. It is huge. It can hold 6,000 people.
It's like
Oh my gosh.
it's bigger than
serious?
Rupert.
It's like you pick up Rupert and add an extra 1,000 people from Burley, and then you got the cruise ship.
Oh my gosh. Okay, so we got 3 on there.
There's 3.
Yeah, let me see. I can't read that. We got
I figured it
Mondays,
out.
Tuesdays, and then today's.
These 3.
Okay, let's see. Test for the 4th unit, Monday, Tuesday. I think he's just reviewing the next couple of days over rotations and shells and things like that. And then the final is, it looks like December 12th. I don't know.
My phone.
You only get 2 hours.
Somebody calling you?
Time.
Wait, only
Yeah.
get 2 hours
Who?
on
Now on a regular test, you get more time.
Who's
the
calling?
final? I
It's
think you can
Brooke.
take as long
She
as
never
you can
calls
take as long
me.
as you want.
Why don't you answer then? She calls you. That's probably
They should
important.
give you
I don't know.
2
Answer
hours,
it.
at least 2 hours, 5 minutes.
It's Brooke.
Call ended.
That's because you let it time out. If she never called you, it's
Okay,
probably
so we're all
clever.
3 of those on. Going.
They're going. I
Hey,
think.
I need you to set me up a place on YouTube for. Did I ask you this for my basketball games?
Yeah.
And now, to do this, do you have to?
Hello?
Does he have to give you a code to get on
Hello?
For
YouTube? These YouTube.
Hello.
We just need to know like the name of the channel.
The
and
It's an Ida fight thingy.
Because I would watch the last.
Have you never heard of it? They did it last year.
For sure. No, it's just.
Oh, then I'm not sure.
Okay, never mind then.
To remind you. All 4 of you. Is that just a code? Or?
Okay.
You just have to send the link through mine. Like we were doing at the beginning of the semester.
Okay.
Stopped.
Stopped.
Bye.
Hey, if you want to go.
Cody, make sure you send the last ones from
Okay.
this week on the reminder.
It's not. Oh, it's 10.
And when we have time, so after your final, we'll have the rest of the month and then a week. You need to teach me how to go on to YouTube and do what you do.
Okay.
Can you teach an old dog to do that?
Probably.
You think so?
Probably.
Okay.
Right. Which one was it? It was 19.
Did Stephanie come in here? Gonzalez? No? Oh, she's dead.
There you go.
Stephanie Archuleta.
That's what I meant, yeah.
Is that what you meant?
Yeah.
Oh, well,
So he's my aide. I have an aide.
You get an aid?
Every now and then they think, hey, that crazy person.
Why is this taking so long?
Because it's a
Oh, okay. There, light.
Sorry.
Thank you.